measure this thing by using photon in, photon out, measure the intensity change. Or you measure, you have very, very thin material, very, very thin, so that everything you can detect from the electron. You can measure the bulk like this. Or you can measure the partial yield, just picking out on there. So you have bulk, you get one set curve, or you put, for example, sulfur atom on a copper 100 surface, and you look at what is the scattering from the emission of the sulfur atom onto the copper surface, right? Because that would generate emission, right? So you are now measuring the sulfur emitter curve, right? And that corresponds to the surface. Okay, so here you have the surface information that you got, right? And this is the bulk information, and then you do a Fourier transform, and you got different information. Okay, so the surface you can get, you can either put an absorbate on this atom, and you look at the full electron wave that come out from the absorbate, or you can simply measure the OJ electron, right? This is known as partial electron yield, from the bare metal surface itself, because we know that from the copper 111, the OJ electron, couple layer down, the OJ electron will not make it to the surface, right? OJ electron can only be detected within 1 nanometer from the surface. So this is totally in the nano regime. So you can pick out, if you can detect OJ electron by selecting the right energy, electron energy, then you can detect the OJ electron. And that OJ electron corresponds just to the surface process, and then you can go through the exact treatment, just like that. Okay. Now, so let me tell you a little bit about the OJ process. It is interesting and it's quite useful if you can understand it. It's a little bit tricky to understand at first. Okay. So let me first tell you the energy level, right? So the energy level, you have 1s electron, 2s electron, and then you have spin-orbit coupling, so you have 2p1 half, 2p3 half, so 2p1 half at 2 electron, 2p3 half at 4 electron, right? So this is how you see it in atomic physics. Now, the physicists don't understand the electronic configuration, so they, instead of calling 1s, 2s, 2p, they just call it KLMM. So the notation for OJ electron, they call K is for 1s electron, and L is anything with n equal 2, M is n equal 3. So this is the n equal 1 shell, n equal 2 shell, n equal 3 shell, 4, 5, 6, and so forth. Okay, sorry, like this. So that corresponds to principal quantum number. They identify by letter. So K shell means 1s electron. Okay. Now, but what happens if you are in K shell? You do have 3 different shells because you have n equal 2. You have 2s, 2p1 half, 2p3 halves, and they have different energy. So how do you label that? So the physicists simply say, okay, I can call this first one L1, second one L2, third one L3. Okay, so when you see this notation, you understand what the physicists are talking about. He's really just talking about same thing as the chemists, and except the chemists are more precise because they use spin-orbit coupling and so forth, whereas the physicists just a label on this. Okay, all these are due to notation, these kind of X-ray notation, and so. When the photon comes in, you create a core hole, right? Photon comes in, create a core hole, and then what will happen? What will happen? So this core hole, when you label an OJ transition, there are 3 numbers. There's three letters that you need. You have the first one, which where the core hole is. So this one. So you have a core hole. The full electron come out from K shell, which means it's at 1s. So this is K, okay? And then the second one the L1 shell is the one that this electron, right? So it's this L1 shell come to fill out the core hole. So this is this going to this. So that's the first process. The upper state going to fill the primary core. But you still have enough more energy, and the emitter for electron, which is coming from here, is from the L3 shell. This one here, you see this one? This one come out. This one go to fill this hole, like this, right? So in the OJ labeling, you have K, L1, L3. Okay, so everybody follow? This is my hole. This electron is from the L1 shell, which is 2s electron. The 2s electron come to fill the 1s hole. And after you complete this process, you still have excess energy, and the OJ electron would then be coming out from the 2p3 half shell. This is coming from here, and this is labeled L3 line. Okay, so in most of the OJ line that you recognize, this notation goes due to SID bond. So you see all this labeling, and you now understand what they mean, right? So this is for clip